Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved all the questions related with exercise number 1.7 related with the linear algebra BSc 8 edition written by Bernold and David R. Hill. In today's video, I will solve the last exercise, which is the most important exercise of chapter number 1 matrices, which is exercise number 1.8. So let's move toward exercise 1.8. This is totally related with the LU factorization. L mean lower triangular matrix and U mean upper triangular matrix. So LU factorization, linear algebra 8 edition written by Bernold, Kolman and David R. Hill. So it tells that there are total 10 questions. So first 4 questions will be solved by this method. Solve the linear system using forward substitution followed by the back substitution. So A matrix is given, B matrix is given, lower triangular matrix is given and upper triangular matrix is given. So over here we have two equations, Ax is equal to B and the second equation is A is equal to Lu. So putting Lu over here in the first equation, so it become A is Lu, so it become Lux is equal to B. Now let's suppose I replace this Ux with Z, so it become let Ux is equal to Z, it become Lz is equal to B. Now over here L is given and my B is also given. So by putting L and B we will easily get the value of Z. Let Z is unknown, Z1, Z2, Z3. So it become over here Z2, Z3 is 0. So it become 2 times of Z1 will be 18. So 2 times of Z1 will be 18. It means Z1 is equal to 9. Now after this multiply 2 with Z1 and minus 3 with Z2. It become 2Z1 minus 3Z2. It will be equal to 3 because Z3 is also 0. So by putting Z1 over here it will give us Z2 is equal to 5. Now over here Z1 minus Z2 plus 4Z3. It will be equal to 12. By putting Z1, Z2 it will give us Z3 which is 2. Now my Z matrix is obtained, which is Z1 is 9, Z2 is 5 and Z3 is 2. Now after this, this is actually forward substitution method. Now we are finding the required answer, the required linear system for the value of x using backward substitution. So we will put the values over here in Ux is equal to Z. Now my U is given, which is 1400210002, and my Z is already found out, which is 9, 5 and 2. So by putting 9, 5 to Z and by putting U, it will give us the value of x, x1, x2, x3. Now by the backward substitution we will start from the third row. So 2 times of x3, this is x3. So 2 times of x3 will be 2, so x3 will be 1. Now over here 2 times of x2 plus x3 will be equal to 5. By putting x3 it will give us x2. Now in the first row we have x1 plus 4x2 is equal to 9. By putting x1 it will give us by putting x2 it will give us x1. So my required solution to the given linear system is 1, 2, 1. Now solving question number 3. A matrix is given, B is given, L is given and U is given, and all is 4 by 4 order. This is a 4 cross 1 and this is 4 cross 4 order matrices. So we will make the 5 equation. X is equal to B, A is equal to Lu, Lux is equal to B, Ux is equal to Z and Lz will be equal to B. Now this is actually 1, 0, 0. This is my L, this is my Z and this is my B. It means that I will use fifth equation. L is given, Z is not given, but B is given. Now by forward substitution, just like we done in the previous question, we will find Z1, Z2, Z3 and Z4. It will give us Z by forward substitution. Now for using backward substitution, we'll use equation number 4. My U is given. This is my U. My X is not given, we will find it by backward substitution, and my Z is given, which we already found out over here. So it is minus 2, 2 minus 24 and minus 16 by putting over here. Now by forward substitution, we will start from the last row. So it becomes 4x4 is minus 16, it gives us x4. Now find for this third row x3, now find for this row x2 and for the first row find x1. So it will give us the required solution to the given linear system. X is equal to 1, 0, 2 and minus 4. Now let's try question number 7. Over here in question number 7, A matrix is given and B matrix is given. So this is very difficult. First we are going to find the upper matrix U and then we will find the lower triangular matrix L. So our A is given, we will do some operation R2 minus 2R1, R3 minus 4R1. Then we will do another operation 6R2 by minus 4. Then finally we will do a last operation R3 plus R2. So this gives us upper triangular matrix from the given matrix A. Because over here the diagonal below diagonal element is 0, it means this is upper triangular matrix. Now from the same matrix A, we will do some operation and we will find a lower triangular matrix. And lower triangular matrix, the element above the diagonal, this is diagonal, so the element above the diagonal will be 0. So this is actually our lower triangular matrix. So this is L and this is U. So L, U, A and B is given. Now we'll use this formula Lz is equal to B. So my L is given, which is this matrix, and my Z is not given and my B is given. So we will find Z1, Z2 and Z3. This is forward substitution. Now use another formula Ux is equal to Z. So my U is given, which is this matrix. X is unknown and Z is given. We find it already, minus 10 by 33, minus 5 by 66 and minus 44 by 99. So we will use the backward substitution. Minus 11 by 2 into x3 will be minus 54 by 99. It will give us x3. Same wise we will make another two equations. 6x2 minus 9 by 2 x3 will be this, and last x1 plus 2x2 plus x3 will be minus 10 by 3. So from over here, by putting the value of x3 we will find x2. So by putting x3 x2 finally we will find the value of x1 finally. So this is actually that will be actually the required x is equal to x1 x2 x3. That will be the required solution to the given linear system.